This is the fourth presentation for today, and it's going to be on unit testing. So the tagline for today is, why test your code when it can test it for you? Unit testing is a form of basically automating our software testing. It's not testing the software through the actual interface. We're testing it by running an application against the project. Typically, when you're in a Visual Studio world of Microsoft, your unit tests are going to be housed within a single project. They're actually code files within that project, and they all live in there. So typically, a unit test is going to target one function in your existing code base, and it's going to try and evaluate that function to make sure it's working properly. Basically, how it does that, as you can see, in each unit test, we have a predefined input, so it'll be hard-coded in some nature into the test itself. It'll attempt to run the function that it's trying to test, and then once that's finished, it'll attempt to evaluate it, check the output, and the goal is essentially that we have, with our predefined input, we know what the outcome should be, and we want to make sure that it is that expected outcome. Why should we bother with unit testing? It sounds a bit complicated, maybe it's too hard. We're writing code essentially that doesn't really accomplish anything. We're not going to see anything flashy on the screen, and we already kind of know how to test our software. You just use it. That's how you test. Well, let's think of an example here. Alright, so we're going to go over a hypothetical project example. So you've just been hired by a big company right out of college as a senior. Woo, money. Money is good. Pay off your student loans as fast as you can. Alright, and the first project they've got you on, you're working on one of their legacy projects. It's a little older. Actually, some of the developers that used to work on it, or maybe even authored it in the first place, aren't even there any longer. And basically, what you've been assigned to do is go into this legacy project, and you need to update it with a few new features, a few new items to make it to kind of bring it into the modern age. So you're excited. This is your first job. You're going to dive right in and start going at the source code. Once you get in there, you kind of realize there are some areas you don't quite understand. You don't know what they're supposed to accomplish, but you kind of phase that out for right now because you want to get your new features in there. Alright, so what do? You start writing code for those new features, and that's going great. And then eventually you reach the point where your new code has to interface with the old code. It's a little bit troubling, but you try and merge them as carefully as you can. And so you get that merge done, and then you start using the software, and it seems to work fine. Your new features, they're working great, they look awesome. You're excited to show people, so you push out an update to your users. And then, unfortunately, you start hearing reports back from your users that some functionality is actually broken. It's actually crashing in ways that it actually didn't even used to crash before, and now everyone is mad at you. You lie down and you try not to cry, and then you cry a lot. Alright, so what really happened here? The project built. We all know that when you build and there's no errors, that means there's no bugs. So what could have we done differently? Could the project been structured in a different way that would have made it easier to detect those errors? The ones where we thought we didn't break anything, but we actually did. Yeah, so are there tools out there that would have made it easier to catch those before we actually sent that update out to our users? The answer is yes, with unit testing. Alright, so now we kind of see the problem that we're trying to tackle. We've got an existing code base that's a little bit too large to fly through at one glance. You can't just make a small change and in a moment try and figure out if that broke anything or not. This is the problem that we're trying to solve, and this is the problem that unit testing is going to help us solve. So as stated before, unit testing is essentially going to target individual pieces of our code base it's going to throw at them predefined input where, given that input, we know what should be on the other side. And it's going to verify that those outputs actually happen. So as you can see, the more pieces of our code base that we can create unit tests for, the more we can validate very quickly, because obviously we're not testing through the interface, we're testing with the program. Programs are fast, users typically aren't quite as fast. Alright, so now we're going to see, we're in the Visual Studio world kind of typically with your projects. So we're going to see how to actually add this to our existing application. So if you were using Visual Studio, you would right click on your solution, you would go down to Add, go down to New Projects, because like I said before, unit testing is going to be added to your application as a separate project within the greater solution. And then once you click Add New Project, you want to find the Unit Test Project template. And then typically when you name your project, you want to name it something, application name, and then unit tests. That way whenever someone, either you or maybe another developer, sees it, it's very clear what that is from the get-go. And then the last thing that you need to do maintenance-wise before you can start using this is you need to add project references. Again, your unit test is a project within your solution. So in order for that project to be able to test your other projects, you need to add references to them. So you can see in our example here, we've got our order parsing application, and then we've got our order parsing unit tests project. So in order for the unit tests to be able to test against our actual application, we want to do a right click, add reference, and then we're going to add a reference to that project. And again, your unit tests, it can potentially target and test every project in the solution. So again, if you've got multiple projects that you are testing, you just add a reference for each one. So we did our right click add project, we made a unit test project, and now we're kind of seeing some code, but it's not really doing anything. It's a bit unclear how to get started with this. How do we actually get to the testing part? Alright, so what we're going to do now is look at some existing examples of unit tests that actually are fleshed out. Alright, here's our first example, and this is a unit test method that actually does something. You can see at the very top the name of this class is Activate Inventory Tests. Again, there are a lot of conventions as far as naming goes. Basically what you want to go for is consistency, because you want to make it easy for you and for other developers on your project to be able to know what is what. A good naming convention is typically activate inventory is the actual method that we're attempting to test. So we're saying this class is going to test that method. And then you can see here we've got the test class attribute applied to that. That's going to let Visual Studio know that there are tests in here, so when we attempt to run the tests, it knows where to find them. Then within this class, we've got our method here. Again, whenever you're naming functions in application, you typically want to keep them short and sweet. However, with testing, you can there's a little more leeway in your naming. You want to name it something so that it's very clear what that test is doing, so that basically anyone who's reading the test name should be able to glean everything they need to know about that method. This one is basically testing that if we have one of these inventory objects, that whenever we call activate inventory, this Boolean flag here, active, is going to get flipped on. So within the actual body of the unit test, again, there's many conventions as to how to actually set up your unit tests, but you want to go for consistency. What I found to be beneficial is kind of this 3-stage setup here. And I've got comments in there to kind of let myself know what each stage is. So the first stage would be the arrange. Basically, all the objects you are going to need for your test, you would initialize them there with your predefined input that we talked about. In the second stage, the act, that's obviously where you actually call the method that you're attempting to validate. And then the third part, the important part, is where you're doing your assertions. So basically, you can see this assert class here. That's a part of the unit test template. There are several different, basically, functions in there that all evaluate to a true or false. You can see this one is trying to say, is this Boolean field true? That will return true or false. And there are other ones in there you can test if an object is null or not. You can test if a value is above a certain threshold. You can test for equality and all those things. Again, this one is doing a little bit different. It's testing against this get inventory notes method. And this particular test class, or excuse me, this particular test method is attempting to validate whether or not this function returns a non-null object. So you can see in our range here, we're creating a notes property or a variable there. We're not initializing it to anything, so it's going to be null by default. Then we attempt to set the value of that with whatever this get inventory notes function returns. And then after that's all done, we want to say, is this object null or not? You're setting up your input, you act on that input, and then you want to see, did what I expect to happen actually happen? All right, so when you're in Visual Studio, to actually run your tests, you want to go up to the test menu, and then you want to say run all tests. The unit test projects operate a little differently than a regular project. There's no concept of like starting a new debug session, even though you can debug your tests, because remember, we're applying our test class and our test method attributes. That's letting Visual Studio know where all those tests live. You could potentially have multiple different unit test projects, and since you can't in Visual Studio, there's no concept of running multiple projects at the same time. Instead of running the project, it's finding all those attributes, compiling a list of all the tests that are going to run, and then actually running them. All right, and then after our unit tests actually run, we get this handy-dandy little status report here. Green checks always make you feel good. It shows green checks for all of our tests that passed. So these are the tests where our asserts evaluated to true. And then you can also see there it actually shows a little timer about how long the test took to run. Another pretty cool thing about Visual Studio is after you do your initial test run, you can actually choose to rerun all the tests, or you can choose to run only the tests that failed. So you can kind of see a list of your failed tests, and you can work until that list is gone. So it kind of makes it a little easier to pass your tests on several runs. Alright, so this is a little mental exercise here. In the context of unit testing, can anyone look at this and see what might be problematic with this code? So basically, one of the things that's going to be difficult to manage with this code is the fact that it does so many different things. I mean, based on the arguments that are coming into it, it can do a whole host of operations. So it's going to be difficult on average to determine what the function is actually doing. We need to know a lot about the given circumstances to know what will happen after this function is done running. Yes, unit tests are good. However, unit tests aren't something you can just kind of throw into your application. There's this greater concept, and actually if you do some Googling, if you simply Google how to write testable code, you will find a whole host of resources on how to structure your projects, how to structure the code in order to make them more testable. Yeah, so you can see your code really has to be designed from the ground up to be testable. It's not going to happen by accident. If you were to work on a project where one of the requirements was to have unit testing, you would really want to nail down how you're going to accomplish that first. If you wait till the end, you're probably going to get bit by that. As we can see in our example previous, if they were going to apply unit tests to that particular function, it would be a mess. Alright, so I'm going to go over next basically several different aspects you want to consider when you're trying to make your code testable, as they say. Alright, so one of the things you want to do is you want to focus on classes and business objects that really handle one particular business item or a small group of things very well. So what am I talking about? I'm basically saying, for instance, let's say we've got a project that involves a customer class. If we can set up our customer class to deal with everything involving customers and only involving customers, then we can be much more certain when we run unit tests against that object that our customer functionality overall is maintained. We know that if our customer unit tests pass, most likely the customer functionality has not been broken after we do new changes. Another thing that can come into play when you're working with unit tests are the idea of static variables and methods. Are you guys familiar with like static versus like instance classes? Yeah, so basically static variables and methods, they're great because you can share things amongst classes. However, they can be problematic when you're attempting to create quote-unquote testable code. Basically, the main reason being is because they are shared amongst the application as a whole. So when you're trying to focus on a particular function to say, does this work, if that function involves static variables and static methods, well, those can be affected by the entire application. It's a little more difficult to run a test against one piece and say, yes, it works, or no, it doesn't, if it's potentially relying on lots of other, like a static variable that can be changed across the board. Another thing is to try and avoid classes that involve overly complicated initialization. Basically, what you want to shoot for is when you're creating these business objects as your classes, you should really only have to call the constructor once, and then your class should be good to run any of its methods across the board. That's really a good target to shoot for. Basically, the problem being, if given the circumstances in which you're using a particular class, if it requires different variations of being set up, it's going to make your unit testing a lot more difficult. Basically, if you've got a class where you initialize it one way when you're in one case versus initializing it a different way in a different case, it's going to make things a lot more divergent. Alright, so in terms of writing testable code, again, you could fill an entire seminar just on that topic alone. And again, an easy way to find resources is to simply Google how to write testable code. You'll find a lot of results. But one that I found particularly helpful, I don't know how to pronounce his name, but I know he works at Google. This guy wrote a guide writing testable code, and I think it's a great place to start. Alright, we've got some disclaimers. As cool as unit tests sound, we do need to make sure we keep them into perspective. Unit testing is not a replacement for traditional testing through the interface itself. Again, we're directly testing against functions themselves. We're not using the buttons and the checkboxes and all that stuff to accomplish it. Again, I kind of made the joke earlier, but just like no compilation errors doesn't mean no bugs, in a similar fashion, simply because you pass all your unit tests doesn't really guarantee that there's nothing wrong with the application. It simply means that your core functionality is working as is. Those predefined inputs that we've set up, they're all passing, they're all doing what they're expected, so we have a greater degree of confidence that our application is working correctly right now. Yeah, again, passing a unit test, it simply means that that functionality is working based on that predefined input that we've set up. If you've got more exotic functions, or if you've got parts of your application that rely very heavily on the interface, those ones are going to be needed. They're going to be needed to be tested through other means, either through some kind of UI tester or, again, simply just using the application. So real quick, let's go through some of the benefits of unit testing. First of all, they're really fast. You saw on the other page that one of the functions took 3 milliseconds and one took less than a millisecond. So basically, once you've taken the initial steps to write these tests, you can run them just with the click of a button, and they can be run over and over again. So that's very advantageous. And naturally, whenever testing is that quick and that easy, you're going to be doing it a lot more often. You're going to catch errors earlier and faster, which obviously is a good thing because we want less errors. That's good. It makes regression testing easier as well. So basically, regression testing is the idea, it's kind of from our example earlier. So it's the idea that when you add in a new piece of functionality to your application, to your website, it's not really enough to just test that new piece. You also need to make sure the way that piece is integrated with the other areas of the application, that it didn't break any of those things as well. Obviously, it sounds exactly like what unit testing is trying to accomplish, because we're constantly running and testing every part of the application, not just one particular piece. You also save time for your testers. Testers are people too. They do get paid for their time, but whenever they're testing a piece that's broken and then fixed and then broken and fixed, it can get a little frustrating. So that's just something to keep in mind. Obviously, as we saw before, unit tests are code, so that means they can be versioned. If you guys are using the versioning tools like Subversion or Git, they're part of the project. So what that means is, obviously, anyone who has access to the project, and obviously developers as well, are going to have access to all those codes, all that code and the unit tests. This is advantageous because not only will the other members of the team have access to your tests, but if they're also contributing to the greater pool of unit tests, you're going to have access to all of their tests as well. This is, oops, a little overflow there. Basically what this means is that even before you've read other members of your team's code, even if you don't understand it, as long as they have tests built in, you can be validating their code and also validating how your newest changes interact with theirs. You can see that's very powerful in terms of constantly checking to make sure that no new errors have crept in.